Have you ever looked up at the night sky and wondered just how far it all goes? The twinkling stars, the hazy swirl of the Milky Way, and the deep silence of the cosmos, they all hint at a mystery far greater than anything on Earth. The observable universe refers to the part of the cosmos that we can currently see and study using our most advanced telescopes and instruments. But even with the most powerful technology, our view is limited. Why? Because light, the cosmic messenger that carries the story of the universe, can only travel at a finite speed. This means that we can only observe objects and events whose light has had enough time to reach us. Anything farther away, or any event, older than the time it takes light to travel to us, remains hidden in the darkness of the unobservable. Interestingly, the diameter of the observable universe is about 93 billion light-years. That's far larger than the estimated age of the universe itself, 13.8 billion years. This may seem impossible at first glance, but it makes sense once we consider that the universe has been expanding. Space itself is stretching, and the galaxies that were once close are now much farther apart. So the light from those distant galaxies has taken billions of years to reach us. Even with all this information, it's humbling to realize how little we truly know. The universe is vast, beautiful, and filled with secrets we've only begun to uncover. Fortunately, with the development of modern tools like NASA's James Webb Space Telescope, we are beginning to peel back the layers of this cosmic mystery. The James Webb Telescope, often called the successor to the Hubble, is already revealing things we never dreamed of. It allows us to study the universe's structure, composition, and history in ways we never could before. Recently, astronomers discovered a massive structure at the farthest edge of our observable universe. A telescope just made contact with it, and it's changing the way we think about the cosmos. As this new frontier unfolds before us, we invite you to stay informed, stay curious, and subscribe to our channel. Like the video, tap the notification bell and join us on this incredible journey across space and time. But here's a question that has puzzled scientists and dreamers alike. What lies beyond the observable universe? To explore those unreachable corners of space, we would need transportation methods that don't just move through space, they'd need to transcend space and time itself. Concepts like distortion drives and wormholes come to mind. Once the domain of science fiction, these are now serious topics in scientific discussion. Some experts believe such travel is theoretically impossible, while others are cautiously optimistic. The debate continues. Can anything travel faster than light? Could we one day cross the barrier that separates us from the truly unknown? Even if we assume such things are possible in theory, creating technology to make them real would be an unimaginable challenge. We'd need breakthroughs in physics and engineering so advanced that they might take centuries, if not millennia, to achieve. Still, some theories suggest the total size of the universe is at least 10 to the power of 23 times larger than the observable part. That number is so large, it defies human understanding. And since we cannot see or measure what's beyond, we have no way to confirm what's out there, at least not yet. But even without direct observation, we can make educated guesses. This is where NASA and international space agencies come in. Working together, they've provided us with glimpses into the early universe long before the Earth was born. Even before the James Webb Telescope became operational, NASA's Hubble gave us the ultra-deep field image, showcasing countless galaxies in one tiny portion of the sky. When Webb launched, it looked even farther. It detected galaxies as they were just a few 100 million years after the Big Bang. The light from these galaxies had stretched into the infrared spectrum, a result of the universe expanding. The Webb telescope is specifically designed to detect that kind of light, helping us study how galaxies first formed. By analyzing those ancient star systems, scientists have uncovered surprising information. Galaxies were forming stars at incredible rates far earlier than we expected. These discoveries suggest that the early universe was far more dynamic and complex than we imagined. And that leads us to a profound realization. If there's so much we didn't know within the observable universe, what wonders might exist in the parts we can't see? One of the biggest questions humanity has asked is, are we alone? The possibility of life beyond Earth is no longer just a fantasy. It's a scientific pursuit. Thousands of exoplanets, planets orbiting other stars, have already been discovered. Using the transit method and radial velocity techniques, astronomers have identified many planets with conditions that could support life. Some of these are rocky, Earth-like worlds located in their star's habitable zone, where liquid water might exist. One fascinating example is WASP 96b. The James Webb telescope examined its light spectrum and found water molecules in its atmosphere. Even more surprising, it also detected signs of haze and clouds, features once thought unlikely on such planets. These findings don't prove alien life exists, but they make the possibility far more real. Considering how vast the universe is, it seems unlikely that Earth is the only cradle of life. If there are countless galaxies in the observable universe, how many more might exist beyond it? And how many of those might harbor intelligent beings? The odds are staggering, and the evidence is building. Another mind-bending idea gaining attention is the concept of the multiverse. In quantum physics, some interpretations suggest that each decision, each event, causes the universe to branch into different outcomes. This is known as the many worlds interpretation. In this view, infinite parallel universes exist, each with different histories, versions of Earth, and possibly even versions of you. While the multiverse remains speculative, it could help explain certain phenomena in physics that are otherwise difficult to reconcile. Some scientists find it compelling, others are more skeptical. But no matter where you stand, the idea of infinite realities is undeniably fascinating. It reminds us how little we know about the true nature of existence. Now let's talk about something real but equally puzzling: dark flow. Discovered in 2008, dark flow refers to a mysterious phenomenon where galaxy clusters appear to be moving in a uniform direction at high speeds, faster than what standard cosmological models predict. One explanation suggests that a massive unseen structure outside the observable universe is pulling them. This could imply that there's something incredibly large and unknown beyond our cosmic horizon. Other studies question the data, suggesting that dark flow may result from observational errors or limitations in our instruments. At present, the scientific community remains divided. But whether real or not, dark flow invites us to explore deeper and question the very boundaries of our universe. In the end, one thing is clear: we are at the beginning of a golden age in space exploration. From the discovery of ancient galaxies to the possibility of alien life, from quantum realities to cosmic mysteries like dark flow, the universe continues to challenge our understanding. It forces us to confront the unknown, to expand our minds, and to ask the hardest questions. So, what do you think? Are we alone? What lies beyond what we can see? Could there be other versions of reality, other Earths, other yous? Let us know in the comments. And remember, this journey is just beginning. Like, subscribe, and turn on notifications so you never miss an update on the greatest adventure of all, our quest to understand the universe. Thank you so much for watching. See you soon.